Okay, this is lesson 2.6, AP Calculus Curriculum, Derivative Rules, Constant Sum, Difference, and Constant Multiple Rules. We're going to start with the video that's going to go to the proofs and a couple of real simple examples. Then we'll do some more examples with each of these. So we start with the rules. The rules tell us that if f of x is some constant function where a is a constant, then f prime of x is equal to 0. Remember, if we have a constant function, f of x equals 3, then this is saying the whole graph is a horizontal line. The y values are not changing. So we end up with f prime of x equals 0. That's all this is saying. Then the sum rule, if k of x is a sum of two functions, f of x and g of x, then the derivative of k prime of x, is equal to the sum of the derivatives. So the derivative of a sum is equal to the sum of the derivatives. That's the way I like to say that. In this case, if you have the sum of two functions, then if let's say f of x is equal to 3x and g of x is equal to, let's go cosine x, then let's say k of x equals 3x plus cosine x, then k of x is equal to f of x plus g of x, and k prime of x is equal to f of x prime of x plus g prime of x, the derivative of f of x plus the derivative of g of x. It works the same way if we have subtraction. The subtraction rule says if k is the difference of two functions, then k prime of x, the derivative of k of x, is equal to the difference. So the derivative of a difference is the difference of the derivatives. And then we have g of x equals a times f of x. So constant times f of x is the constant multiple rule. This just says that the derivative of g of x is equal to the constant times the derivative of f of x. So these are all rules we're going to prove. We'll start with this derivative of the constant. We start and let f of x equals some constant a, and we know that f prime of x is equal to the limit as h goes to 0. We have to know this limit definition. We have to know how to use it, of f of x plus h minus f of x all over h. Well, the limit as h goes to 0, f of x plus h, if f is a constant function, it means it doesn't change the value regardless what x is. So f of x plus h is a, and f of x is a. So I have a minus a over h when I plug in for x plus f of x plus h and f of x, which is the limit as h approaches 0 of 0 over h. Well, regardless what h is, this equals 0. So this is just 0. We did earlier. We'll do examples in the next proof. But that's the rule. So we have the derivative of a constant is 0. And when you understand the constant is the rate of change, the derivative is the rate of change, a constant never changes, so the rate of change in a constant has to be 0. That's always the case. Always the case. Now the derivative of the sum rule. Let's say we let k of x equal the sum of two functions, f of x plus g of x. And again, we have k prime of x by the limit definition. This limit as h goes to 0 of k of x plus h minus k of x over h. And since k of x plus h just means I plug in x plus h for x everywhere there's an h, or everywhere there's an x, then that means this k of x plus h is f of x plus h plus g of x plus h. Now subtract k of x, which means I subtract f of x plus g of x, and that's all divided by h. This is the limit as h goes to 0 of f of x plus h plus g of x plus h. When I distribute that negative sign, minus f of x minus g of x all over h. And I can reorganize the numerator. That's the limit of f of x plus h minus f of x plus g of x plus h minus g of x all over h. And because limit properties tell me that I have a limit of a sum is the sum of limits, I can look at this as the sum of these two quantities all over the same denominator, which means I can split them into two fractions. So this is the limit as h goes to 0 of f of x plus h minus f of x over h plus g of x plus h minus g of x over h, which is the limit as h goes to 0 based on limit properties of f of x plus h minus f of x over h plus the limit as h goes to 0 of g of x plus h minus g of x over h. And since these are just the limit definitions of f prime and g prime, that means that this k prime is equal to f prime of x plus g prime of x. So the derivative of a sum is the sum of the derivatives. This really goes along a lot with the limit definitions because the derivative is defined by a limit. The difference property is going to be the same way. If I let k of x equal f of x minus g of x, I'm not going to go quite into so many steps. I may skip a couple steps because this is very similar to the proof from before. Then k prime of x is equal to the limit as h goes to 0. It's very important you understand this limit definition of, k of x plus h minus k of x all over h. And this is going to be equal to the limit as h goes to 0. Remember, when you're working through these, never lose your limits, of f of x plus h minus g of x plus h. That's my k of x plus h. Now I subtract k of x, so I'm subtracting f of x minus g of x. That's all over h. And this is equal to the limit as h goes to 0. This is going to end up being f of x plus h minus f of x. When I distribute the negative and reorganize, minus g of x plus h plus g of x all over h, which is the limit as h goes to 0. If I pull that negative out, write this as two fractions and pull the negative out of the second one, I get f of x plus h minus f of x over h minus, now g of x plus h minus g of x over h. If I distribute this negative, I get negative g of x plus h plus g of x. So this is correct, which is just the limit definition of the derivative of f of x minus the limit definition of the derivative of g of x. And the limit properties say this is the limit of the first minus the limit of the second. And this is the definition of f prime of x, and this is the definition of g prime of x. So we have k prime of x equals f prime of x minus g prime of x. And the difference of, the derivative of a difference is the difference of the derivatives. And finally, the constant multiple rule. This says if we let f of x, or sorry, let's g of x equals some constant number multiplied times f of x, then we can say g prime of x is equal to the limit as h goes to 0 of g of x plus h minus g of x over h, which is the limit as h goes to 0 of a times f of x plus h minus a times f of x all over h. If I factor out that common a up top, I get the limit as h goes to 0 of a times f of x plus h minus f of x all over h. And we learned with the limit properties that a constant times something in the limit can come outside as the constant times the limit. So this becomes a times the limit as h goes to 0 of f of x plus h minus f of x all over h, which is just a times f prime of x. So the derivative of a constant multiple of a function is the constant multiple times the derivative of the function. And those are the rules covered in section 2.6 of the AP Calculus curriculum.